Hello everyone, hope you all are doing well. So in today's video, we will be looking at how we can reverse engineer C hash binaries using DNSpy. Okay, so let's get started. So for today, what we have here is we will be looking at a few C hash binaries and reverse engineer them to get to know a bit about like how we can use DNSpy and also we will see how we can reverse engineer them to achieve our goals. So first we have here DNSpy like 32-bit version and 64-bit version. So both these versions we have to use according to what type of binary that we will be trying to reverse engineer. So first step here is we have to understand what is the target binary. So the first binary that we will be having a look at is the Cracknet binary over here. So this is basically a reverse engineering challenge I found on the internet. So let's have a look like how we can understand about whether the binary is 64-bit or a 32-bit binary. So for this, the tool that I'll be using is the hex editor tool. So let's load the file in it. So as you can see over here it shows this L character. So that means that this is a 32-bit binary. Okay. So for example, let's have a look at a 64-bit binary as well. Mm. So here we have this DLL. So again, here, as you can see here, we can see some characters like DT or D plus, and looking at these characters we can have an understanding that this binary or DLL is a 64-bit. Okay, so as we have analyzed, the Cracknet binary is a 32-bit binary. So let's fire up DNSpy. So before starting with the binary itself, let's have a look at what and how DNSpy works. Okay, so here we have DNSpy and the application or the binary that we would like to reverse engineer, we can load it using these options. So here we have it loaded, and here we have multiple windows that we will be using during the debugging process. Okay, so these windows can be enabled or disabled via options that we have over here. So when we start DNSpy in the default, like once we install it, these all windows will not be there. We will have to get them from debug windows. And here we have multiple windows like breakpoints, module breakpoints, output. Also in view, we might see a few more windows. Okay, so based on our requirements, we will be adding more windows here. So let's have a look at what each window does and what is the use. So the first window that we have over here is breakpoints window, and in this breakpoints window it will allow us to see where all places in the code we have placed breakpoints and navigate through them. Okay, so let's say if we place a breakpoint over here, this will be shown in this window itself over here. Okay, clear as of now. So the second window that we have over here is module breakpoints. So this window over here will allow us to pause the execution of our program when a particular module or a library is loaded. Okay, so in this window also we will be able to see what modules are being loaded by the program. Okay, so we have here modules window also. So here also we will be able to see what all modules are being loaded by the program. And here in this window we will be able to set breakpoints for any specific modules while being loaded. So the option that I have set over here is we can set add breakpoint or remove a breakpoint. Remove, so we don't have any breakpoint as of now. So let's add a breakpoint. So here we can mention the name of the module that we would like to set a breakpoint for. So as of now, what we can do over here is I will specify a wildcard value, that is star. So what this will do is it will break the code for each and every new module that is loaded by the program. Okay. So the third window that we have here is output window. So this window in a debugger is a console-like window that displays messages, warnings, errors, or any other output that in the program itself that is related to debug. Okay, so it can also be used to log output of variables or helpful messages while debugging the program. So the next window that we have here is the locals window. The locals window will display current variables and values of those variables, also the parameters in the current scope of the program, also like what all variables are being used by the current function that we are debugging. So all these information will be shown in the locals window, and it will show us the values of variables in real time as the program is in progress. So once program executes, the values of these variables will change. So all this information will be displayed in the locals window, and it's one of the very important windows that we use while debugging. So here we have call stack. So call stack window will display the sequence of function calls as we are executing the program. So when the program execution is in progress, there will be like function calls sequentially, and all these function calls will be seen here in the call stack itself as per the sequence up till the current execution flow as the program is progressing. Again, we have here memory. It will show us the memory of the program itself, and this is an interactive console. If you want to send any commands to the application. All right, so enough about the DNSpy itself, and let's get started with the first binary that we will be working on. So as you can see, I have already loaded it. This is the Cracknet exe that we will be trying to reverse engineer. So before we go to reverse engineer itself, let's have a look at what it does. So as we can see here, it is asking us to enter a password, and it will check if the password that we are entered is correct or wrong. And if we enter the correct password, it will, I think, show us a flag. So as you can see, we don't have the correct password, and guesswork is not going to work here. So let's load this application into the DNSpy. So as you can see, the application is loaded over here, and mostly for console applications you will be able to find the main class under the program. Here the main class will be there most of the time for console applications. Okay, so let's have a look at the code. So here we have functions of the program: print banner, game over, guesses, timer. Okay, so looking at the main function, what we can see over here is it will ask us to enter some password. It will read the input that we are giving, and looks like it will do some comparison operation. And if we are able to get the correct value, it will show us a flag, else we will get the incorrect password again and the game over. Okay, as we can see, we have 5 guesses allowed before the application exits. If we are able to put the correct passwords, it will execute this function. So let's execute the program itself and have a look. So here we can use this field to pass any arguments if we want while running the application, but as of now we don't have any arguments. So by default our program will be program will break at loading any modules. As you remember, we had set a module breakpoints. So here let's see, the first module ms corlib has been loaded. That's why the program had stopped the execution. So let's continue the execution. More modules are being loaded. Okay, so we have a breakpoint over here. Okay, before moving on, we have 3 more important options in DNSpy that we should have a understanding of. So here we have 3 buttons: step into, step over, and step out. So these buttons can be used for moving through the execution flow of the program. So step into, so this command or like this button lets the application execute the next action. So if the action involves a call to an operation, it will step into the implementation and break the execution on the first action of that implementation. Okay, and then we have here step over. So the step over command or the button allows the application to execute the next action if it involves a call to an operation. It does not step into the implementation though. It will not step into the implementation, but like it will complete the implementation and get out of it. And here we have step out. So this command lets the application execute why until the currently executed operation implementation is returned. So I think we will have a better understanding of these three while working on the code itself, working on debugging of this binary itself. Okay, so basically if we want to go inside the implementation of a function, we will use step into. If we want to just complete the function execution and get the return value, we will use step out. And if we want to uh, like call an operation or execute the next action, then we will use step over. So let's continue the execution of our program until we see the Cracknet banner over here. So I will be stepping out. As you can see in the locals, we are able to see a lot of variables and those values which are being executed currently. Okay. So here we have a prompt to enter the password. Okay. So let's try entering any random value and I press enter. So it says incorrect. So what I will do is pause the execution of the program and we will look at what exactly is happening and try to understand. So I have entered a wrong password again and press enter. So we will be having a look at the variables. If you remember, like while looking at the code, we saw like it is taking input from us and comparing it with some value, and then it will execute the next function upon like what is the result of the comparison. So now that we have entered this value, we will try to look for this value in the locals to see uh, like which variable is saving it and when is the comparison being done. Also in the call stack we can see which function are we working in right now. So this is currently the readline function that is being executed. So what it is doing is it is reading the input that we have given. Okay, coming back to our locals. Oops. Oh, we were supposed to step over. Okay, no worries. Let's try again. Here we have pause the execution. enter a password and press enter. Okay. Okay. So looks like we are in the main function, and the value of the text that we have entered is here, and it is making a comparison of the text to the value, and the value um will contain, the string value will contain the decrypted contents of this string. Okay, so as we can see, before making the comparison, the value has been, this line has been executed, and the output has been stored inside the value field, and then it will make a comparison. As we can see, the value here is the high ground, and it is making the comparison, but I don't think it will pass. And here we will get the output as incorrect. Let's continue the execution, and here we have an attempt for a new password, and as we saw in the previous step, the password that was being compared to was the high ground. Here we put the password and press enter. Let's keep on executing the program until we come back to the main function again. So again, the readline function. Okay, so I think not sure why it is showing the previous entry that we had given. Okay, yeah, so it was the previous value of the variable. Okay, so now that value has been updated, and we can see that we have the same value in text and value as well. Now we are stepping into the implementation and looking at what exactly is being executed. So this is the decrypt AES function that is running right now. So previously we had seen it in the main function itself, in the main class, and here what it is doing is decrypting the uh, given string. So this is the ciphertext that the program is trying to decrypt. And this is the decryption function being run. And here we can see that after the execution has completed, the result has been stored in this result variable, and the value of it has been stored inside the value variable, value string. So let's let the program execute, and as we can see, we have the flag. Okay, so moving on, let's come to the second challenge that we will try to solve. Second one we have here is uh, that we have to extract some kind of password or a secret key that is being used to work with the database that is there over here. Okay, so let's have a look at what the program is before we start. So it looks like we must specify the database path. So if we specify the database path, let's see what happens. Okay, it will show us some error. Let's load it into DNSpy. So here we have crypto.dll as well. Let's first have a look into this because I believe this, but let's see if this module is being used by CASC first. Arguments, we need to mention the database file. So this is the working folder, and the file name was audit.db. Okay, we need to use a 64-bit DNSpy because this is a 64-bit binary. Okay. Let's jump to main. Yep. Let's start the execution. Right, look at modules, ms core lib, the CASC audit, and as you can see, CASC crypto module is also being loaded. Okay, and here we have a breakpoint. So the thing that we are looking at is related to passwords. So that's why we will be having a look at this crypto DLL. Mm, okay, yeah. I think we can see here encrypt string and decrypt string functions. So looking at the decrypt string functionality, what we can see over here is it is taking two parameters, the encrypted string and the key as parameters. And again, it's creating an object of AES type, mentioning the key size, block size, the static IV, also the uh, decryption mode will be CBC, the key, and the string. So they have initialized a string which will contain the output once the uh, function has decrypted the input. Okay. So what we can do over here is we can either set a breakpoint at return itself, because this is the uh, value that we are interested in, or we can also look at execution sequentially as the program is executing. Okay, so let's start. Let's continue executing the program until we come to the uh, encryption or decryption functions. As you can see, the folder for that we mentioned for the audit.db file has been stored in the base directory variable. The list of modules that have been loaded. Here we see some SQLite connection requiring values of password and strings str2. Let's have a look how it is working. So as you can see, if we are using the step over function, it will uh, it will execute the program line by line and also show us what all values are being there in the variables here. But as of now, let's keep on moving to the next function until we come to the decryption stage. Okay. Okay, so I think here we have this AES create. So it has created an object of AES, and as we can see here, the encrypted string is this, and this is the key that we will be using for decryption. So this is not the actual value that we are looking for, but this is the encryption key that will be used by the decryption algorithm to decrypt this encrypted string. Okay, so the things that will be required for decryption will be the key size, block size, cipher mode, and the encrypted string itself, and the decryption key. So this is the key. So we will move like execute this program step by step now. So here the values are being initialized. All right, all right. As you can see that we have uh, reached the end of this function, and in the string variable we can see that the decrypted string has been saved. Okay, so that really completes our goal, and this was what we were looking for. Okay, so this was the method that we use to execute it step by step. What we can do is also we can set a breakpoint and let the program execute entirely, and directly we will be able to reach here when this breakpoint hits. As of now, we will continue and restart our program to see the second method. I think it will show error as we had seen previously, and exit out. Yes. Okay. Now that the program has exited, let's have a look at breakpoints that we have. So the breakpoint that we had set is over here at the return string functionality, return string. Okay, so let's start the program. We have mentioned the arguments as required. Working directory also is correct, and now we will be letting the program execute. Again, let's have a look at what modules are being loaded. Our breakpoint has not been hit yet. Okay, now we can see that our breakpoint has been successfully hit, and let's look at the locals. As you can see, we are able to see the value of the string variable. Okay, so this completes our second challenge as well. Moving on, the third challenge that we have over here is this is one of the challenges from the Flareon CTF. So this is the challenge itself. Let's have a look at the message that they have given us. So this is the simple game. So we have to reverse engineer to figure out what weapon codes are there to defeat each of the two enemies. Okay, so we have two enemies and we need to get the weapon codes. Before running the program itself, let's run it normally and see what it is doing. we have to enter some weapon code to stop this marauding tabby frigate. Okay, interesting. So let's fire up DNSpy. Let's load up the executable. Let's go to the main function. Again, this main function, we can browse it from here also. Here it should be there in the program. As you can see, here we are in the main function. And what we can see here is it will show us some logo and stage 1 form object is being created. So let's have a look at what stage 1 form does. Okay. So here we have this fire button click. So as we had seen previously, we are clicking, we are entering some text and clicking on the fire button, and then it will tell us if we have entered the correct code. So looking at this function itself, oops, here we have back and forward button as well that we can use. So it is comparing the text, as we can see from the code itself, to this characters, okay, rainbow. So this should be the uh, code itself, I believe. So let's start the application and see what happens. So let's set a breakpoint somewhere when it hits the stage 1. Okay, you can see the breakpoint here. Keep the window in locals. Okay, start the program. Here we don't need to specify any arguments. It has stopped because of the modules ms corlib. Let's continue. Let's continue until we hit our breakpoint. Okay, I think we have hit our breakpoint, stage 1 form. So now it is running the stage 1 form itself, and let's put some wrong um, input first, okay, and see what happens. Let's set a breakpoint in the fire button click function as well, in this place, to see what happens. Okay, so as we can see, our breakpoint 2 has been hit, and let's have a look at locals. lot of variables. As you see that the input that we had given, it's stored over here. We should receive the invalid code. Step out. You can see we have the invalid weapon code. Now let's try to enter the correct one. I think we have our breakpoints. Breakpoint 2 has been hit. Let's step into the function. Let's let the program continue. As we can see, we have successfully completed the first challenge itself. And I think we had 2 stages here. And the second one that we have is perimeter defense kitty. I think so. Yes. So let's have a look at the second function, okay? The stage 2 form. So here again we have the fire button click function. But in this case we don't have a hard-coded text that is making the comparison, and but instead what we have is a function that is checking for the code that we enter, okay? So let's have a look at this function. Clicking on the function, we will come here to the implementation of the same, and as we can see over here, looking at the code, what it does is it will take some string as input and make the comparison. So what it is doing over here is it is doing XOR operation with A. So here we have this array. This is the array itself. And each value of this array is being XORed with the A. Okay. So what we can, as you know already, let's discuss about the XOR operation first. So as we know, the XOR operation is like a reversible operation, and what if we XOR any two values and output of the same, if we XOR it with any of the previous values, it will show us the remaining value. So it's a reversible operation. So let's have a look at like how XOR operation works. Okay. So let's say we are trying to XOR any two values. Mm, let's try to XOR A with B. So as you can see, the output we have 3, and what we can do is XOR 3 with B to receive A again. Okay. I think we will need to print the ordinal value of this, sorry, character value. Yes. So as we can see, it is a reversible operation, and what we can do is we can uh, XOR this array with A itself to receive the string. Okay. So we can write a quick function in Python to automate this task. So here I have this small function over here which is doing the same. So here we have the encoded values, and these are the values from here. This is the array itself, and what we are doing is we are XORing each character in this array with A and saving it in the DEC and printing it out. Okay. So running this Python script, the value that we have here is this one. Let's try to enter this value again in the program to see if it works for us. So let's set a breakpoint here also. As we can see, we have a breakpoint hit. Looks like the comparison has been successful. That's why we are into the line number 110, and let's continue the execution of the program. Looks like we have successfully executed this challenge as well. Successfully completed. And here we have the flag. So this was it for today. So if you have any feedback, or would you like to know more about, or if I have missed uh, anything regarding the functions or the functionalities of DNSpy, or what more content would you like to see, please let me know in the comments. So thank you all for watching the video. See you guys next time.